start?
Yeah, you can go ahead whenever you're ready.
Yeah, so today I'm going to be presenting about building search over medical literature with retrieval-augmented generation. For just a little context about myself, my name is Elise. I'm currently a machine learning engineer at Capital One. So I use retrieval-augmented generation, or RAG, pretty frequently in my current work. Um, so just for starters, RAG, what is it? Or RAG, or retrieval augmented generation. Um, so RAG is pretty much the culmination of a search component and an LLM. So the benefits of using RAG as opposed to just prompting an LLM is that LLM does have some sense of knowledge cut off. It doesn't know everything, and it also tends to cite anything it knows. So it might cite something like Reddit as like a source for an answer about, for example, we're using it for medical search. So sourcing Reddit for medical search, that might not be what you're looking for. It also can hallucinate a lot on its own. And if you have something like private documents or more up-to-date documents that aren't publicly available, it also doesn't have access to that in just pure LLM form. So using a RAG is beneficial. So the basic structure of a RAG is the user has a question. The user might ask a question in our case, like, um, what are some treatment methods for, I don't know, type 2 diabetes, for example. It could then retrieve relevant documents based on this query. So the search finds relevant information from an external knowledge base that is relevant to that question. Then the LLM uses retrieve context. So it gives that information to the LLM as context so it can generate a grounded response. And then as a result, from that original user question, we have a grounded answer. So to go over the major steps of the RAG pipeline architecture, and we're going to be going into each of these steps in more depth in later slides. But the first thing we have documents. In my example, I used PubMed documents and the abstract specifically. Then we chunk those documents. We create embeddings from them and place those embeddings in the vector database. Then the user would ask a question. That question would then also be converted to an embedding. And using similarity search, we can retrieve the relevant chunks to that user's question, which we can then add as context into a prompt that we send to the LLM. And as a result, the LLM will give us answers and citations for what documents or what chunks were used in answering that question. So, document chunking. LLMs work better with small focused pieces of information. So we retrieve only sections relevant to the user's question. Chunk size is really important when we're thinking about chunking up the documents, something that choosing a chunk size that is too large will add irrelevant information into that chunk. And choosing a chunk size that is too small will basically lead to important context information that should be in that chunk getting lost. So often when we're trying to improve a RAG, we can sometimes mess with chunk size to see what the right size is for our project. Overlap is also something we want to think about. So repeating a small portion between neighboring chunks helps preserve context when an important sentence spans two chunks. So often we can start at something like 10 to 20% overlap and mess with those numbers also if we are seeing a different number or percentage resulting in better retrieval or better search. We also want to store the metadata for each of these chunks. So in our source of truth, or the source that we want to add into this database. So something for us might be like the paper citation data from PubMed, the author, the title, the publication. So in short, good chunks means we get more relevant retrieval, which means we have better context to put into our prompt to the LLM, which will result in better answers. On the embedding side, so after we have chunks, we want to embed those chunks into a vector database. So instead of using text like heart attack, for example, we would use embeddings. So embeddings convert text into numerical representations, also known as vectors, that capture meaning. So heart attack as text might be converted to a list of numbers. Embeddings place similar concepts close together in a vector space, which we're using a vector database. So that's kind of the vector space we're talking about. And similar meanings lead to similar vectors closer together in that vector space, which will lead to better semantic search. So when we're using a vector database, instead of using something like keyword matching, where you're just matching the word heart and attack, pretty much, we're using semantic search, or something where similarity of meaning is what we're actually searching by instead of the exact keyword. So talking a little bit more about vector databases, the vector database is a searchable memory for the RAG system. So it stores documents, embeddings, and metadata, and then it also indexes those vectors for efficient search. It compares a query embedding against those stored embeddings, and then from that returns the top K most relevant chunks. For example, okay, it could be an adjusted number, 5, 10, 20, depending on your use case. Traditional keyword search, as I was discussing before, looks for matching words, but vector search looks for a similar meaning or similar semantic meaning. So in the right, we can see in the example we're using, boats and ships are similar and close together in that vector space, even though boats and ships in like a keyword search would not equate to each other because they're not the same word. So when we're thinking about the retrieval process, just walking through an example, with our example of user asking, what are common treatments for type 2 diabetes? What would happen in kind of step by step if we ask that question in our RAG example? First thing that would happen is we want to have the query embedding. So we're putting that query into the same kind of context or system that the vector database is in. And then using that, we're doing a similarity search where we retrieve the top K relevant chunks. In our example, those K relevant chunks might be sorted, citing the diabetes guideline, medication comparisons, or ADA recommendations. And then that context information is put into the prompt that we are going to send to the LLM. When we're thinking about using this context information, another important aspect to creating a RAG is the prompt construction. So once we've asked the question, sent that question to the vector database. We have our relevant information. How do we send it to the LLM? We want to construct a good prompt. So in our case, it might be something like, you are a medical research assistant answering the user's questions using only the provided context. Then you add the context, which is our search result from the vector database, the user's question. Our question in this example is, what are the common treatments for type 2 diabetes? And instructions. These specific instructions are kind of trying to reduce the risk of hallucinations or kind of going off base, off something that maybe isn't factual. So the instructions here are base your answer on the provided context. Do not make up information that is not supported by the context. Cite the relevant sources when making factual claims. If the context does not contain enough information to answer, say so. And so now I'm going to walk you through a live demo I created. I also have the link to the repo in my notes or resources section. So if you guys want to look at it on your own time, it's very possible. So this is the example RAG I created just to make it a little easier to run locally and to kind of narrow the scope of the project. I added 200, chunked 200 abstracts and added those to the vector database. And these abstracts were from PubMed, but they're also only about dermatology. So if there is a question that we have that isn't in those 200 abstracts, or the information isn't there, the results are not going to be as good. Or hopefully it will even say, oh, we don't actually have information about that, instead of hallucinating or making up a result. But like if we ask a question like, what are the treatment options for plaque psoriasis? We can see it going through the steps. So it's embedded the query. Now it's searching through the vector store, seeing what the semantic similarity is to vector store items. We can see it's retrieved those relevant abstracts. Now it is sent those relevant abstracts with the prompt to the LLM, and it is now generating a cited answer, and it's saying it's done. So it retrieved these abstracts. So it looks like treatment with biologics in chronic plaque psoriasis. So this is about treatments for psoriasis. Another document about psoriasis, and it's looking at the similarity score. So it's saying that this has a 0.279 similarity score. This has a lower similarity score. And we can see that the most similar is actually the one most relevant to us, or the treatment with biologics, in where it's actually talking about treatment for psoriasis. And then it is produced this answer. So based on the provided abstracts, here are the treatment options for plaque psoriasis. And it's working through those treatment options given the context we gave from the abstracts. And then it's providing citations, which are just citing those abstracts that are here. So some common challenges that we might see in a RAG type solution is poor chunking. if the chunks, as we talked about, are too big or too small, it can really affect whether there's information that is relevant that should be included in a chunk and it's left out because the chunk is too small, or if there's information that is really irrelevant and the chunks are way too big, which would affect semantic search. Wrong documents retrieved, which kind of related to chunking as well. If the search isn't working as well, we might want to mess with something like chunk sizes, or maybe top case similarity, or adding more documents into the vector database. Missing context, maybe the documents that would answer the question we're asking just aren't in the vector database. Outdated data, kind of a similar thing as missing context, except the vector database information isn't up to date. So there might be an outdated plaque psoriasis treatment that is still in the vector database. So it's just giving more information because it has bad context data. Hallucinations despite retrieval. As we looked at in the prompt, if you're prompting well, you really want to prompt saying, please don't hallucinate, please only use the cited information. That being said, sometimes the LLM will still hallucinate. So really changing the prompt and messing with like how you reduce those hallucinations is another common challenge of building in RAG. So some methods of improving a RAG system, and these are some basic ones, but there's also a lot more advanced methods in terms of chunking and search and adding in graph databases and all these other cool things that you can do. But as we talked about, better chunking, so optimizing the chunk size and overlap to preserve useful context. There's also metadata filtering. So in our case, metadata was that citation data. So we could narrow results by source, date, topic, author, or other metadata. If there was a specific journal for psoriasis, we could narrow it down by that journal. That might help our chances at doing a really good document search. We could do hybrid search. So this combines that semantic similarity search, vector search, with that more traditional keyword search method that we were talking about, where it's just word matching as opposed to kind of semantic search. If we do both, then we'd have an even better output to our search. You could use re-ranking, so retrieve a larger set of candidates, then use a re-ranker to select the most relevant results. And query rewriting, so you could transform or expand the user's question to improve the retrieval. So if we think, what are the treatment plans for, or treatment options for plaque psoriasis isn't a thorough enough question, or it isn't asking the question in the right way, we could transform that query and rewrite it to be better for the LLM to respond to. And finally, for some key takeaways. So RAG combines retrieval with generation to ground LLM responses in external knowledge. This is super important for something like medical data, where we really want to have a known, reputable source for the answer we get from these types of questions. A typical pipeline includes chunking, embeddings, vector search, prompt construction, and an LLM. Retrieval quality has a significant impact on answer quality. So the more we improve that retrieval of relevant data, the better context we can give to the LLM, and the better the answer will be. And that medical search is a strong use case, as I just talked about, because accuracy, transparency, and citations are really important. Here's some sources. So this is a live demo I just showed and a link to that repo, but also some good like beginner sources for RAG, as well as some specifics on chunking strategies, vector databases, and then some cool kind of RAG techniques that you can use to improve or have a more advanced RAG. But yeah.
It was so cool. I love that you went into the specifics of how to use it. I think the hackathon participants could really use this to make sure that they're getting good data for the projects that they're making. So thank you so much for presenting on that. That was really, really great. And if there are any questions that you guys have in the audience, you can go ahead and put them in the chat so we can wait a minute on those just in case. Can you clarify your question just a little bit? Are you asking how to build that research base? And if that's what you're asking, then I would definitely go ahead and look at the resources that Elise was talking about. Maybe those can help you. I'm not sure if she can help specifically with your question, but Elise, if you want to take a stab at it, you can.
Yeah, I mean, I would say for anything like very specific, like oncology or I guess my example uses dermatology, it's just kind of making sure that you have the right data. So I use PubMed abstracts, but kind of like narrowing down um, the kind of factual medical information you have about that, and then making sure all that is in the vector database.
Okay. Yeah, so it seems like the core of that is just making sure that you have good data, and then you can build as long as you do your research properly. I think I saw one more person typing, but I don't see them typing anymore. Oh, okay. Can we get the PDF for reference once before the hackathon? Yeah, we're going to be sharing all of the slides and everything once all of the presenters have finished their workshops for the day. We'll be putting that in one of the resource channels as well as sharing the recordings on our YouTube channel. But if there aren't any other questions, I think that will conclude the workshop. If you guys can say thank you to Elise in the chat, that would be awesome. All right, and we will see you guys at the next workshop. That's probably going to be starting in about 10 to 15 minutes.